Hello guys, welcome to this video on how to do the 2014 FRQ problem number 1, only number 1. First I'm going to do part A. So in part A it asks for the average rate of change, and to do that we need the function. So I'm writing down the function, and then for average rate of change it wants a specific equation. The equation is 1 over b minus a from a to b, f of x, d of x, and this will get you the average rate of change. So you plug in the numbers, 1 over 30 minus 0 from 0 to 30, 6.687 times 0.931 to the power of x dx. And then you plug this function in, which I've already done, and you click enter, and then you get 2.752635, and this is the average amount of grass in the container over the 30 days. So now moving on to the next section, which is section B, and this section asks for the derivative of a at 15, and we're supposed to find the meaning of this value in the context of the problem. So first off, we start with the equation 6.687 times ln 0.931 times 0.931t. And this is because of the rule of when finding the derivative of an exponential function, it is a to the power of x times ln of a, and a is the value that's in front. So this is why we do this. So now we plug all these values into the calculator and we get negative 0.163591, and this is the rate at which the grass is decomposing at 15 days. Alright, so now on to part C, which asks to find the time of t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval from 0 to 30. So we have to use the average value, and as I'm already writing down is the 1 over 31, and this is equal to 2.75. Well, this is a rounded value, and the actual value is in my calculator. And this number is the average amount of grass. So now with this value, we set it equal to the original equation that we had to find the value of x. And as you can see, it is an exponential, so we're going to have to use some log rules. And the log rule we're going to use is log base ax is equal to b, and this is equal to b is equal to x. And this is really nice because it helps us with this equation. And as I said before, I'm writing down short values because I don't want to write that much, and I'm just writing down rounded values, but the real values are in my calculator, so my answers aren't. So my answers are correct, but the values that I have on my paper aren't. Okay, so sorry you couldn't see my work, so I'm moving it up now, and that's what we got. Log 0.931 0.411634, and this is equal to x. So the only thing we have to do now is to plug it into the calculator, which I've already done, and this is our value. It's 12.4148, and this is our time, which means it is days, and this means the days that it took for the amount of grass in the bin to be equal to the average amount of grass from 0 to 30 days. Okay, so now moving on to the next section, which is part D, and this part wants us to predict at what time will there be 0.5 pound of grass clippings remaining in the bin. So we have to use the linear approximation to A at t equals 30. And that equation is f of A plus f prime of A times x minus A. So we plug them in and we get f of 30 plus f prime of 30 times x minus 30. And I'm going to give you the rounded values of these numbers because I don't want to write that much down. And it's not going to affect the actual answer because I'm going to have the actual value on my calculator and I'll give the actual answer later. So we get 7.8 minus 0.05 times x minus 30, and this is equal to 0.5 because we want 0.5 pounds of grass clippings. So then we subtract 7.8 from 0.5 and we get negative 0.28, and then we divide by 0.5 and then add 30 and we get 35.544, and this is the amount of days that we predict that it will take for there to be 0.5 pounds of grass left in the bin. Thank you for watching Learning More with Felipe Ramos. I'm out. Bye.